Today on This Week in Health IT.
We don't look at ourselves as the intrusion detection system per se. We look at ourselves as one more element that can feed into a SIM, as an example, sort of a security architecture. Now you actually have something baselining and looking at these devices that can feed into that SIM, that can feed into the network access controller, right? To actually go and take action.
This is a solution showcase. My name is Bill Russell, former healthcare CIO for a 16 hospital system and creator of This Week in Health IT, a channel dedicated to keeping health IT staff current and engaged. If you want to be a part of our mission, you can become a show sponsor as well. The first step is to send an email to partner@thisweekinhealthit.com. Just a quick note before we get to our show, we launched a new podcast, Today in Health IT. We look at one story every weekday morning and we break it down from a health IT perspective. You can subscribe wherever you listen to podcasts at Apple, Google, Spotify, Stitcher, Overcast, you name it, we're out there. You can also go to todayinhealthit.com. And now on to today's show. We're going to talk about securing the clinical network within the hospital and actually into the community as we expand beyond the four walls and into the cloud. We have two guests with us today. We have Anand Srinivas with the Office of the CTO, Service Provider Edge Business Unit for VMware. And we have Paul Jones, Global Director of Product Management for Network and Security Solutions for GE Healthcare. Gentlemen, welcome. Welcome to the show.
Hey,
thanks for having us.
This is an interesting topic, and I'm looking forward to having it, not only because this was a problem when I was CIO, maintaining the clinical devices, knowing where they are, and making sure that they're connected and reliable was always a challenge for us. But it's changing. The world's changing, and we're starting to even move beyond the four walls of the hospital. So I think this is really a timely topic because I'm curious how we're going to manage that now that it's going outside the four walls of the hospital we're actually placing those devices. But not only that, some of the endpoints that we're collecting the information isn't within the four walls of the hospital anymore. And so it's an interesting dynamic environment. All right, Anand, I guess we'll start with you. Give us a little context. How are clinical devices connected, tracked, managed, secured, and monitored today? And what challenges does that create for health systems?
Yeah, for sure. And so, yeah, even before we get outside the four walls of the hospital, there's a big challenge even just in the hospital. And what I would sort of say to start is that medical devices today are just on a variety of different networks. Some devices are on OT networks, operational technology networks, that are completely separate from IT networks. I'm sure Paul can talk about sort of the GE patient monitoring telemetry devices, such as like the Apex, FH, and CH devices. Some of these medical devices are over separated networks, completely physically separated, running proprietary protocols. And an example, again, Paul can sort of address, are the GE CareScape network devices. And then some devices are completely unified on the IT network. So ultrasound machines, for instance, operating over Wi-Fi, that's completely on the IT network. And then you have user devices like the doctor's laptops or workstations on wheels. You have the guest networks, right, that sort of interact with all of this as well. And so when you think of like this holistic environment of medical devices and basically all of the devices operating over a hospital network, it gets really challenging to have visibility both into the performance of all of these devices, right? For instance, can these devices connect to the applications that they're trying to access, like the critical applications like EMR systems or PACS servers or whatever else, or in the case of guest networks, maybe Netflix and whatever that needs to get watched, right? Can they connect? And then, what's the security of these devices? Your MRI machines better not be talking to servers in Russia or whatever it is. And so making sure that that's all locked down is super important. And just the myriad of the type of devices that are out there, these aren't built by networking companies. These are built by companies that put a cheap network card in there. And so there's a big challenge in terms of trying to figure out what these devices are doing. Are they performing like they're supposed to? Are they talking the right protocols that we would expect? Are they connecting to the application? Are they secure? All of those kind of things. But yeah, that's kind of what I would say.
Yeah, the only thing I would add to that is that there's also generations of devices. I mean, there's some devices that are 10 plus years old that are on the networks. And then there's some new devices that are brand new and they're communicating with different protocols. They've got different levels of drivers and patches and communication protocols. So it isn't like everything is new and designed for all the risks and challenges and optimal traffic flows that you have today. So when you think of it that way, sometimes you need to use the technology to protect those devices, like technology like the network and like security systems and other things. In other cases, you're using the latest and greatest devices, and sometimes they kind of stomp on each other when they're interacting. Some of the new protocols work differently or assume that you've got quality of service and all these prioritization mechanisms that the old ones didn't have. And the old ones, if they're medical devices, it's very difficult to update and change those systems. You can't just go install a new driver on a medical device. I mean, it's a very long process to do an update. So
I'm trying to remember back to the problems we had. So obviously we had security. Security's top of mind. Everyone's looking at security. You have performance issues, but you just have some tactical issues. Like, I don't know where the devices are. I mean, it might sound silly to somebody who's listening to this show, but we had devices that ended up on eBay. We had, just walking out the door. And I remember when they came to me and said, how do you not know where all these devices are? I'm like, you can go onto the floor and ask them where the device is, where it's supposed to be on that floor, and they won't be able to find it. So there's not only the logistics or the performance and security, which we're gonna talk about in depth, but there's also just the practical of where are they at? Are they patched? Are they running? Does that sort of summarize the problem set, or is the problem set even bigger than that?
No, I think that's an excellent point that, some of the seemingly easiest problems, like just even identifying the device, right, that's operating on the network and ensuring that it's even on the network and up and running and where they're located. I mean, those are pretty challenging problems, actually, that sort of are addressed by the solution.
And there's like a day-to-day aspect of it too, because you've got biomed engineers that every day they have to plan maintenance, they have to plan upgrades, they've got new devices coming in. So a lot of times it's like, where do you go to find out what the status of the device is? Is it where we think it is? Or like they may have one system that says that device should be here, and then somebody has to go hunt around and find it. The nice thing is there are really good real-time location systems, and there's ways to tie all that information together where you can go to like a dashboard and see that information.
Great. Here's what I'd like to do to break this conversation down. I'd like to look at two distinct use cases. One is the traditional use case within the four walls of the hospital. And then I'd like to look at the future, what's going on as we leave the four walls of the hospital. So let's start with the hospital. Traditionally, we've had a network that's already installed. You've talked about that you can even have additional networks installed for some of these biomed devices, different protocols. So they're not just TCP/IP protocols. They can be using a lot of different things to transport across there. We have VLANs where we segment out these devices, and that's primarily for security reasons, because as you said, we can't update these things. And that was a major challenge for a lot of us. Help me to understand, Anand, I'll start with you. Help me to understand how the traditional approach is changing.
The traditional approach are sort of Band-Aid and duct tape, basically, but it's network monitoring systems, legacy network monitoring systems, plus a lot of manual CLI-based intervention into systems to try and figure out what's going on. It's extremely reactive, right? It's after there's a problem and after sort of doctors and patients start noticing that there's a problem, that's when sort of everybody gets into action. But there's no proactivity. People don't know about problems before they happen. And so network monitoring systems are monitoring network elements, but nothing more. They have no visibility into the actual end devices. And as I said, it's only when people start complaining that people realize that there's any kind of issue. And you can't even verify that the problem has been fixed because, again, it's just all anecdotal. And so going forward, and today we're 2021, that approach just doesn't cut it anymore. IT wants a proactive approach. And so the type of solution that everybody should be looking for nowadays in these kind of systems is a system that basically first can collect data that describes every end client device in the network, not just the network elements like switches, routers, Wi-Fi controllers, and things like that, but actually have visibility into what all of the devices, the ultrasound machines, the MRIs, the doctor's laptops, whatever have you, are actually doing on the network and how they're communicating over the network. And so for this, different data sources need to kind of be pieced together to figure out what every end client device is doing. And so the system needs to look at packet data as an example, to look at exactly what devices are talking, what type of protocols are they talking, who are they talking to, what are the latencies and the response times of their communication. So that's the packet data portion. Then to sort of complete the picture though, you also have to talk to other systems. So like the switches and the routers to see where they're connected, the sort of location question, right? Of where they're connected, are they successfully connected? Wi-Fi, what access point are they connected to? What's their signal to noise ratio on those access points? So having sort of a picture of these devices on different protocol or different systems. Talking to network access controllers, knowing which segment they're on, which VLAN they're on, be able to sort of turn around and take action based on that. If a device doesn't get authenticated, why did that happen? What's the reason code and things like that. And then finally, be able to talk to the applications themselves and get perspective from that side. So critical applications like Citrix, VMware Horizon, Epic, right? Zoom in some cases, right? Basically, as much information that can be collected from all of these different systems about the performance and security of every single end client device. And then collecting this is one. If you just collect this, then you've just made the problem more complicated because you've just collected a ton more data. So really, you need analytics to sort of put all of this data together. And you need to be able to identify now proactively, all right, what are all the devices on my network? What are all of them doing? If they have problems, the system should automatically detect that problem and alert IT and everybody else, IT or biomed or whoever needs to solve the problem, and actually give what the solution thinks is a root cause. So, hey, this workstation on wheels is not able to communicate with Citrix because it's got really poor Wi-Fi, as an example. Or this device is not able to connect because the switch went down or something like that, right? So actually be able to provide a root cause of it and then sort of make things sort of easier and more proactive, and also have enough analytics and baseline to be able to say, this is what normal, look, this has gone out of whack. And actually you fix the problem because we verified that the baseline of all of these devices is now back to normal and actually doing well. And so that's really the big challenge, and sort of going from legacy, which is kind of manual monitoring systems, CLI, things like that, reactive, to sort of a proactive, continuous monitoring where a system is actually monitoring it and doing all the analytics and correlation in the background so that what's actually provided is the actual insight. And then we'll talk about it later, but there's another element of this of actually taking the action as well, and the system turning around and actually enacting the change.
No, that's interesting. Let's start with this. Just so everybody's on the same page. We're talking, this is a VMware solution. It's a software solution. I mean, talk to us about the solution itself. Like if I were going to get it and put it into my health system, what would it look like?
Absolutely. The solution is called VMware Edge Network Intelligence, but in our partnership with GE, our special healthcare version of this is actually GE OnWatch NP. That's the solution name. And if you're hospital IT and wants to see the solution, basically the solution sort of has multiple elements. One of them is what we call a crawl. And this device basically collects all of these different data sources that I talked about. So it looks at packet data, right, inside the hospital. It talks to Radius servers and Wi-Fi controllers and switches and routers and things like that over different protocols, whether those are SNMP or the packet data that's protocol agnostic, or whether it's some API that's required to talk to Wi-Fi, and things like that, collects all of this data. And the solution itself is based in the cloud. So the crawler is extracting metadata from all of these different systems and sending the metadata back to the cloud where all of the big data analytics happens, right? And so that's sort of how the solution is architected. And of course, customers can choose, you know what, I don't want things going back to the public cloud. So AWS is one option for us. But if they want, they can actually deploy the backend in their private cloud as well, so that they can have all the data stay on premise.
You give an idea, literally years working with the Niansa and then VMware team on the solution. We built a custom dashboard with them that was kind of tailored to the biomeds and the critical devices that they manage. So we can see in a nutshell, what are my priority alerts? What are my problematic devices? And then that's kind of stacked ranked by the impact that you'll have on the hospital or on the people. Like if it's an infrastructure problem, that'll be a higher priority than an individual device that's having an issue. But we can also see total inventory. We can see where devices are, work closely with them to get it working on our CareScape networks. GE has thousands of these networks deployed all over the world. And these are the segregated networks in many cases where customers want to protect their legacy devices or just their clinical devices by having them on a separate network than the rest of the systems in the hospital. And those networks are protected. They're sending patient monitoring data, telemetry data, electronic medical record data. And we put their sensor on and we're able to have a lot of visibility into what's happening, who's communicating. Is the communication normal? Are there abnormal things happening, or are there unauthorized devices on those networks? So it can start to play into a security role by making sure that only the right communication's happening over the networks during business.
It sounds like not only is GE a solution provider here, but GE is a significant user of the solution. Paul, give us an idea of how GE uses the solution. I mean, again, thousands of health systems, CareScape. I mean, you have a lot of different people that are required to maintain those systems and whatnot. How are you using it?
Yeah, when you look at it from a customer perspective, there's a before, a during, and an after approach. So before we implement a new patient monitoring system, we could install the system and do a baseline of the customer's network to see how are things working and look at basic operational things like, is their DNS working properly? Is DHCP working properly? Are they having wireless coverage issues and things like that in general? Then we deploy the new system. We can use it to determine are all the devices addressed properly? Are they configured? Are there proper communications between the individual devices and the central monitoring stations or the other application servers or the flows to the EMR? Do those all look good? Are they within baseline? Then we're good to go. Then when you get into situations where there's problems, there could be outages, there could be devices that have a flaky network card, or there could be a wiring issue, or there could be a wireless performance issue. And there tends to be a lot of finger pointing over, oh, it's the device, oh, it's the network, oh, it's the application server, oh, it's the protocol, whatever. But oftentimes the different groups will try different solutions and not necessarily fully coordinated. So with this type of system, you can go to one place and see what was the effect of the change. Did it get better or did it get worse? When did the problem happen? When did we get the protocol dropout? We can really do some deep analysis to figure all those things out. And it can really become like a single source of truth across multiple different organizations. And that includes GE field engineers. We've got thousands of the biomeds in many companies are actually GE employees that are maintaining these systems. So even just being able to use the system to go locate the equipment, is it admitted? Is it available? What version of software is it running? Where is it located? That's very useful information that can help them get their job done more efficiently.
Anand, when you talk about I want to say the network behavior, the appropriate, I mean, we're baselining the appropriate network behavior. That becomes a pretty interesting security control because it's watching this device, which is going back and forth between one or two locations. Now, all of a sudden, it's going 3 or 4 locations where it didn't before. I mean, that's something that you would pick up on. That's something that you would alert. We always talk about, and we're installing more and more intrusion detection systems on systems and whatnot. This becomes an intrusion detection system across the entire network almost if you can baseline the correct behavior.
Yeah, the way the system works. So there's the performance aspect, and then this gets us into some of the security aspects. And like you said, take an example, like an MRI machine, right? Shouldn't be talking to Facebook and Google and places like this. And so really, it's probably talking to a DNS server, it's probably talking to a Radius server and application server, right? And that's all it really should be talking to. And so what happens is the system, as exactly how you said, can baseline that, can say that normally this MRI machine is doing exactly this. It's talking these protocols and it's talking to these destinations. And it's sort of, this is its baseline behavior. All of a sudden, if that changes, exactly as you said, we can pick that up. Oh, it started talking somewhere else. And that's out of our baseline of what this device should be doing. And now, basically the way we look at it is we don't look at ourselves as the intrusion detection system per se. We look at ourselves as one more sort of element that can feed into a SIM, as an example, right? Sort of a security architecture. Now you actually have something baselining and looking at these devices that can feed into that SIM, that can feed into the network access controller, right? To actually go and take action, right? So utilize other existing security elements in the system, feed more appropriate data to them, right? So that they have more insight into all of the potential security issues that they could be having, and then potentially even take an action based on that, if that's what the policy is. But of course, one needs to be very careful about that. Have a deny policy on something like an MRI machine. That would be potentially disastrous. So all of these things come together, but absolutely, network analytics and behavior, it's one of these things that in hospitals now, I think everybody has to be on security, right? So even network engineers are now security engineers. So these lines sort of all get blurred together between performance and security, making sure that the device, well, one thing that I've heard is sort of the most secure device is a device that you just unplug and leave in the closet, right? but obviously that doesn't serve anyone's need.
Not the most useful device, just the most secure.
Right.
Exactly. Right. But, obviously that doesn't help anyone. And so there's sort of this give and take between, wait, the device has to be performant and do its job, but we also have to maintain security with sort of behavioral analytics and things like that. And so these things kind of come together.
I think this becomes really interesting as we start to step outside the four walls of the hospital, because a lot of people listening to this would go, yeah, I already have, I have controls and VLANs and I'm doing all this kind of stuff. But like you say, it's retrospective and it's very reactive. Hey, we have a problem here. Oh, go look at the controls, figure that out, that kind of stuff. This is software-based, deep packet inspection. It's seeing what's going on in the network and letting you know in real time as it's happening. But when we start going outside, we don't have those same controls that we once had on all these devices, but you continue to operate. And so for a use case here, Paul, I'd like to start with you. We looked at the GE Mural solution. I'd like for you to talk about that a little bit, and we'll use that as a backdrop for talking about how this solution would support something like the GE Mural solution.
Sure. So Mural is a newer solution from GE, and it's a virtual care solution. So if we use an example, like let's imagine we have a children's hospital that has a lot of pediatric specialists, and now they want to provide a monitoring service for other hospitals where they might have pediatric patients in their ICUs or in different parts of the hospital. And the children's hospital wants to extend its reach within a region by doing remote monitoring. So Mural is set up where it can receive diagnostic information like imaging. It can receive live audio and video streams of the patient to do remote observation. We can receive EMR data from the remote system's medical system. And then we can do health scoring with the tools that are built in. We can see a patient snapshot, and we can see a population surveillance survey of like a summary of patients that we might be monitoring. So all that information could come back through the networks between unaffiliated hospitals. So you might have one that's one brand across town or 3 counties over, and you got the children's hospital that's doing the observation. So they could have like a war room or a nerve center of people doing that observation. Our next solution came in well, let's talk about the problems in doing that. You've got different kinds of data. Some of it is like near real time, actual like what's happening from the patient monitor. So that's what we typically do on local area networks. We typically don't send that across the WAN. And then we get things like audio and video, which could be high bandwidth, high utilization flows where you want to observe the patient. So you mix all these different types of data together and you could have some congestion issues where some things block other things, like especially if you're sending like, send me that latest x-ray and it's this giant file that you need to shove down the wide area network pipe. So that's where we could have dropouts, we could have unperfect data. So this is where an SD-WAN type solution like what VMware offers really becomes interesting. And some of the technologies that they have, Anand can talk about those in more detail, but by bringing those together, we're able to extend between cloud-based systems, remote hospital systems, across hospital networks. Sometimes they have large campuses where they have built medical centers and users in different places. So sometimes they want an overlay network just built over that. So there's some unique technology that we're getting from VMware to put it all together.
I'm listening to that as CIO and I'm starting to sweat. So Anand, what are you going
to do? First, we got to get you a handkerchief. No, I'm just kidding.
Exactly.
No, what I would say is, I think the traditional, again, sort of going from legacy to what we need to do now, traditionally, you would build sort of a dedicated WAN network, right? You'd go over MPLS or something like that, sort of maintains your quality of service, pay a lot of money for that, and try and build out your WAN network that way to support things like GE Mural, like the way Paul was talking about. But in the modern era, A, that's way too expensive, and B, Mural is being built cloud natively in Azure, as an example, right? So a solution like that just isn't optimal. And so SD-WAN comes into play here to sort of guarantee an SLA for people connecting into GE Mural, into a cloud native solution like this, reliably over an imperfect or an inherently unreliable WAN, potentially, right? Where we can now start to combine things like MPLS can still exist as one WAN link, but you can also use cable, you can use DSL, you can use satellite, whatever it is, depending on the situation. And the key technology in VMware SD-WAN is something we call dynamic multipath optimization. And what this does is it creates this overlay network over all of these unreliable links, but it's able to do per packet steering based on if any link fails, it's able to react to that immediately. If an application requires additional reliability because, say, one of the WAN links starts to become really choppy, right? There's a lot of packet loss or there's heavy latency. It's able to add forward error correction in order to fix that kind of issue. There's another side to the solution, which is in the cloud called the VMware Gateway. So on the campus or in the branch or in the hospital or in the home, there's a device called the VMware Edge, right? So this is one router that sort of exists on this side. And then in the cloud, there's something called the VMware Gateway. And then, of course, in data centers and in other parts, there could be other edges or hub nodes as well. And any communication between two VMware SD-WAN devices is protected by this dynamic multipath optimization. So it doesn't matter what underlay you bring to the party, whatever WAN links you want to bring, the VMware SD-WAN solution is automatically protecting and guaranteeing an SLA over that. And that's super important for a mission critical application like GE Mural that has so many different types of data going over it with different types of SLA requirements and things like that, like Paul talked about.
A couple of things I want to hit on. One is we talked a little bit about cloud providers, and more of the data is getting collected in the cloud, Azure, AWS, wherever it's going to be collected, and we're accessing it there. And so you talk about the SD-WAN solution, you talk about having those endpoints. If I'm going to Azure, if I'm going to AWS, if I'm going in another cloud provider's direction, how do I get that kind of capability that you just described?
In the case of VMware SD-WAN, this is actually offered as a service. So our gateway, so what you would deploy on your campus.
So your gateway is sitting in Microsoft's data center.
Precise. It's sitting in Azure, it's sitting in AWS, it's sitting in Equinix, in hundreds of POPs around the world to be able to provide this automatically to SD-WAN customers. And so that's how we guarantee that for cloud native applications, whether those are your own applications hosted in Azure or AWS, or whether those are third-party applications like Office 365 or Zoom, that your traffic is sort of optimized up to the cloud, up to the gateways, and then provided a really quick on-ramp to get to the actual application in the cloud. And there's a lot of automation built around that. But the key thing is that our gateway service is an actual service. So you don't actually have to do anything as a customer to sort of access all of that.
We've talked to some health systems that are talking about adding thousands of beds in their community and not adding a single additional hospital room. And so I want to put you guys into the home, right? And actually higher levels of acuity in the home. So what we described in terms of being able to do that remote to different hospitals and offer those services to other hospitals, we're actually going down into the home. This solution able to scale up to that level back and forth?
Yeah, absolutely. We actually released recently a work from home package around SD-WAN. And the key thing here, I think the main use case is telehealth, obviously, right? Where doctors and providers really need to get that visibility into the home network or into the home or that home bed to make sure that the patient is doing well with all the telemetry from devices, as well as video and audio and things like that to support the patient. And this is, again, sort of a bread and butter use case for SD-WAN, because your WAN link from home is, you're not going to get MPLS to your home. You're going to get DSL, cable, whatever, depending on where your home is located, maybe even worse than that, right? And so you need SD-WAN to be able to protect, where even on a single link, the SD-WAN solution can react in real time. Hey, there's packet loss. We better add more forward error correction, right? There's issues with, if they're lucky enough to have multiple WAN links, there's issue with one WAN, let's switch over to the other. You need a system for that. And SD-WAN, I mean, that's an absolute bread and butter use case that COVID has really accelerated for us at VMware.
So Paul, when you're describing Mural, I assume you're also going into the home with that solution.
Right now, it's primarily aimed at the hospital, but some of the observers and the back-end people, they could be in different locations. They could be in the home and whatnot. But we are looking at those other use cases as these health systems expand and take solutions more to the home for sure.
See what I'm doing as a CIO? I'm pushing you to the next thing that I need.
Right.
Sounds like a feature request.
Yeah, it's right. So if somebody's listening to this and going, all right, this sounds great. I'm a little confused. Do I go to GE? Do I go to VMware? Where do I go to talk about these various solutions? Where do they go?
Well, GE sells versions of the VMware technology that we have OnWatch Network Edge, which is our SD-WAN solution for Mural. And then we have OnWatch Network Performance, which is more of the performance analysis, what we were talking about for the earlier use cases, like providing the visibility into what's happening within the hospital and on the Carescape network, for example.
Fantastic. What didn't we cover? I've started to ask this question at the end because people are like, "Oh, I wish we would have talked about what didn't we cover that would be interesting for the community to hear."
One thing, I'll kick us off. Well, one thing I think is, as we move, as you said, outside of the four walls of the hospital, out to the wide area network, out to services like GE Mural, with all of this healthcare data, security also becomes a new kind of challenge, right? And it's one thing, sort of our traditional security models where we have everything in the data center, we pipe all the data back to the data center, and then from the data center, it goes back, hairpins back to the cloud. That just doesn't work in sort of a cloud native environment where everything now is in the cloud. Again, whether it's third-party apps or your own apps or anything like that. And so at VMware, one of the additional sort of things that we're working on, and we actually recently released, is a solution we call VMware SASE, which provides additional security services along the same path as you go from an edge to a gateway. And then within that POP, you get additional security services like cloud web security, like CASB, services as well. And in addition to that, it integrates with sort of a zero trust network access kind of framework, where devices that maybe aren't going over SD-WAN, or you're like connecting from a coffee shop or something like that. Well, that device can now sort of have an app on it that enables connectivity directly into what we call our SASE POPs. So our SASE POP is sort of an extension of the service that we started out with providing the SD-WAN gateway, but now we're expanding that to provide security services as well. So this becomes sort of an optimized on-ramp onto cloud applications that not only gives you SD-WAN in terms of all of the network protection and network optimization that gets, but also provides in the same pathway security services alongside of that. And Paul, that's probably the next conversation we should be having between VMware and GE as well.
Paul, we'll give you the last word. Is there anything we didn't cover or anything you want to touch on?
I think we covered most of the main points. I mean, obviously the security area is still top of mind. We plan to implement more security capabilities in the solutions. We have other like managed service security that GE Healthcare provides. And our goal is to get all these things linked up just to provide more points of presence to try to stomp out more of this ransomware that's all over.
Yep. Fantastic. Gentlemen, I want to thank you for your time. I want to thank you for the education. It's good to see that this stuff is progressing past where it was back in 2015 when I was struggling with it. So appreciate all the work. Thank you.
This is great. Thanks a lot.
Thank you.
What a great discussion. If you know of someone that might benefit from our channel, from these kinds of discussions, please forward them a note. Perhaps your team, your staff. I know if I were a CIO today, I would have every one of my team members listening to this show. It's conference level value every week. They can subscribe on our website, thisweekhealth.com, or they can go wherever you listen to podcasts, Apple, Google, Overcast, which is what I use, Spotify, Stitcher, you name it, we're out there. They can find us. Go ahead, subscribe today, send a note to someone and have them subscribe as well. We want to thank our channel sponsors who are investing in our mission to develop the next generation of health IT leaders. Those are VMware, Hillrom, Starbridge Advisors, Aruba, and McAfee. Thanks for listening. That's all for now.